Hi everyone. In today's lesson, we're going to talk about how to write a quadratic equation given the roots. So before we can do that, we first have to recall the difference between factors and roots. So let's just say I give you this trinomial and I ask you to factor and solve. So we know that the leading coefficient is 1, so we would do a little add multiply. Now, just for purposes of time, I'm just going to give you what it should be. So it's x minus 2 and x minus 3 are your factors. And when you do your t-chart, you're going to set each piece equal to 0 and solve. So your solutions would be positive 2 and positive 3. So what I want to do is explore the difference between the roots and how we can get back up to this original function here. So there's a nice little trick that we can do. We can take the sum of the roots and we can take the product of the roots. So since these bottom ones here are my roots, right? Let's take their sum. Now remember, sum means to add. So we're going to add 2 and 3. That gives me 5. Now we're going to take their product of the roots. Remember, that means to multiply. So we're going to do 2 times 3, and that gives us 6. So remember how we did add multiply? Isn't add another word for sum and multiply another word for product? So look at the sum of the roots. It's 5, right? But in the equation, it has to add to negative 5. And the product is 6, which is exactly the same that's here. So if you're noticing something, that the sum of the roots is the opposite sign of the A, and the product of the roots is exactly the same, that pattern will work every single time. So to make a quadratic equation in this form, it's going to be as follows. It's going to be x squared minus the sum x plus the product equals 0. And that's exactly what we will get here. So this formula, x squared minus the sum x plus the product, will be the way that we get our quadratic equations. So I want to just write that nice and big here so we can use it throughout the lesson. So let's see how we can use this. So the question says, write a quadratic equation with integral coefficients that contains the given roots. So that fancy word integral just means positive or negative whole numbers. Okay, so we need to write an equation with whole numbers, positive or negative, that contains the given roots. So what did we say we could do? We could take the sum of the roots, and then we could take the product of the roots. So sum means to add. So in this first problem, we have 9 and negative 5 are my roots. So let's add them up. 9 plus negative 5. So when you add that, you get 4. Now let's look at their product. So product means 9 times negative 5, which is negative 45. So what we're going to do is we're going to plug these values into our new equation. So we know that it's x squared minus the sum x plus the product equals 0. So we have x squared minus the sum. Well, we know that the sum is 4, so we're going to put that in here. So minus 4x, we're bringing down this next term, plus the product. So plus, my product is now negative 45. So this negative 45 goes in for my product. So plus negative 45. Now, I put that in parentheses because there was 2 signs, plus and a negative. So you have to remember that when you have plus and negative, it's the same thing as saying minus. So x squared minus the 4x minus the 45 equals 0. So that is your final equation. So this is the quadratic that will produce these 2 roots. All right, let's try another example. What if I give you one that has a fraction as a root or a 0 as a root? So I know it's a little confusing, but you're still going to do it the same way. you're going to say, well, what is the sum of the roots? Remember that sum means to add. So we have 0 plus 2/3. That just gives me 2/3. And then the product means to multiply. So we're going to do 0 times 2/3. And 0 times anything is 0. So the process is the same. You just might not like your answers, right? They're a fraction, there's a 0, but let's just do it the same way. So it's x squared minus the sum x plus the product equals 0. So let's plug in what we know. We have x squared minus the sum, which is 2/3. So that's going to go here. And the product is going to go here. So 2/3 minus the sum is 2/3, x, plus the product, which is 0, equals 0. Okay, so if we simplify this a little bit, we get x squared minus 2/3 x equals 0, right? This is not necessary. But the problem with this one is that the question said that they wanted integral coefficients, or positive or negative whole numbers. This 2/3 is actually a fraction. We can't have this as a coefficient. So there's a trick that we can do to get rid of it. And what that trick says is whatever the denominator number is, you're going to multiply the left side of the equation by that and the right side of the equation by that. So since the denominator is 3, I chose to multiply both sides by 3. And I'm going to show you why this works. So on the right side, 0 times anything is 0, right? 0 times 3 is 0. 3 times x squared, if we distribute it in, will give us 3x squared. And 3 times negative 2/3 x, if you put that in your calculator, you'll get negative 2x. So notice what it does is it gets rid of the fraction, and now we have an integer coefficient here and an integer coefficient here. So take a couple seconds, pause the video, and put 3 times 2/3 in your calculator to see that you get 2. All right, let's look at example number 3. What happens if we have radicals as roots? We're still going to do it the same way. We're going to take the sum and the product. So let's do the sum first. We're going to add 3 plus 5 radical 2 plus 3 minus 5 radical 2. So if we combine like terms, right, that's what we'll do for adding. 3 plus 3 will give us 6. And if you notice, we have a positive 5 radical 2 with a negative 5 radical 2, so they'll cancel. So it's just left with 3 plus 3, which is 6. Then we have the product. Product means to multiply. So we're going to take 3 plus 5 radical 2, and we're going to multiply it by 3 minus 5 radical 2. This might take a little bit of time, but that's okay. We're just going to double distribute. So 3 times 3 gives us 9. 3 times negative 5, you multiply the 3 with the negative 5, and then you just tack on the radical. So 3 times negative 5 is negative 15 radical 2. Same thing over here. You're going to multiply the outside number with this outside number. 3 and 5 gives me 15. So positive 15 radical 2. And then we're going to multiply 5 radical 2 by negative 5 radical 2. And the way that you multiply those, you multiply the outside with the outside and the inside with the inside. So 5 times 5, or 5 times negative 5, gives me negative 25. And then 2 times 2 is in the inside, so that gives me 4. So to simplify this, you should notice that negative 15 radical 2 and positive 15 radical 2 will cancel. You should also notice that the square root of 4 is 2. And then when you do 25 times 2, you get 50. So it's negative 50. And then you have this 9 from the front. So it's 9 minus 50, which gives us negative 41. So our sum is 6, and our product is negative 41. So remember, it goes x squared minus the sum x plus the product equals 0. So x squared minus, the sum is 6, so I'm going to plug in 6x plus my product, which is negative 41. Again, I'm using parentheses because I have two signs, plus and negative. We know that that's the same thing as minus. So x squared minus 6x minus 41 equals 0. So what I'd actually like you to do is try number 4 on your own and then hit resume when you're ready for the answer. All right, take a look at what I got. All right, so my sum, I got negative 8. And then when I double distributed this product, I had an I squared, which I changed to a negative 1. And then when I added them together, I got 52. So my sum and my product. And then I put it together in this equation. Since I had a negative sum, I had to use it with parentheses. So a double negative made a positive. And then my product was just simply positive, so I left it as 52. So if you have questions on this, on either how we got the sum or the product, we'll definitely go over it again in class tomorrow. All right, that's it, guys. Have a great night.